In this video, I'm going to show you how to work with the BIOPAC software on a school computer. Now, I am not hooked up to the BIOPAC machine, and so I am just going to analyze only. So you'll see this if you're not hooked up to the machine. If you are hooked up to the machine, then the computer isn't seeing the hardware. And so make sure that the unit is on and then click retry. For this example, I am just going to analyze some data only. Okay, so I'm going to review some saved data. Again, if you want to actually use the BIOPAC and record your own data, there will be a list of options down here, and you'll just select which program you want to actually run. So here, I'm going to review some saved data. And we want to open a file. So go to this PC, Windows C, Program Files, BIOPAC, BIOPAC again. You want to go to Sample Data, presumably in English, Sample Lesson Data, and I'm going to show you Lesson 2. Gale's data. And so what we're going to be seeing here in just a moment is the end result of an EMG experiment. What we see here is essentially the electrical activity of essentially the arm and squeezing this device. Here we see a squeeze and then a relax, and then a squeeze and then a relax, and a squeeze and relax. Similarly, we see how much force with which this person, Gale, squeezed the hand dynamometer. Okay, next we see this little black line right here. That essentially is when the program told Gale to pause the recording. Okay, then she got ready for the next type of trial and then recorded more data. She clenched as hard as she could with her dominant hand, the hand dynamometer, squeeze, 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 squeeze. And as we can see over time, she her muscles became fatigued. And so she squeezed until about until her muscles were producing about half the force they were at her strongest. Okay, again, black line means that she stopped the recording. She actually switched arms and then repeated the trial. So here, her non-dominant arm, she squeezed, relaxed, squeezed, relaxed, squeezed, relaxed. Okay, paused again, and then squeezed as hard as she could, and then we can see that she got fatigued much more quickly. And so in this lab, we are going to be analyzing the electrical activity as well as the clench force. And so up here, we can see these values here. So this is channel 41, so referring to the clench force and the average. And here is channel 40, the integrated EMG, so the electrical activity, the average of that. The value, so the highest value within a particular highlighted region, and I'll show you that in just a moment. And 40, so delta T here, so the change in time. So when we highlight something, we can figure out how many seconds that particular event took. And so to analyze, let us first zoom in. Okay, so let's zoom into the clench force here. Now, as I zoom in, this gets really difficult to see. And so I want to go to display, auto scale waveforms. Okay, we can also say display, auto scale horizontal to zoom back out. Okay, so once again, I want to analyze this right here. So display, auto scale waveforms. And so now that kind of redoes the y-axis here so that we can actually see each of these different peaks. And then you're going to go to I-beam, okay? And you are going to highlight the entire clench peak. Right? It's a little bit easier to highlight the channel 41 clench force as opposed to the electrical activity, the EMG, even though when I highlight this one up here is highlighted as well. And so as I have highlighted that region, up here I can see channel 41, the average of this right here is 9.598 kilograms of force. So you can write that down in your table. Similarly, the mean of the electrical activity is 0.0379 millivolts per second. Okay. The highest value within this region here is this. Okay, so 10.55, and the amount of time that I highlighted is 1.646 seconds. Okay. So you can continue to do this, okay, and highlight and get the mean of both. Okay. For the time to fatigue exercise, okay, you might want to zoom all the way back out, so auto scale horizontal. Okay. And here you are going to highlight the entire thing. Oops, actually, you're not going to highlight the entire thing. Pretty much look for wherever the force is strongest. So here, I've just clicked, and what I can see is that that particular value, wherever that cursor is blinking, that is about 40 kilograms of force. Okay, so that is the max clench force, right? Gail squeezed the hand dynamometer at a maximum force of 40 kilograms. And then I'm going to divide this in half, so about 20 kilograms, to figure out what at what force has she lost about half of her squeezing ability due to fatigue. Okay, so then I'm going to highlight from the beginning. I'm going to be looking at the 41 value for a time when her clench force sinks down to about 20 kilograms. Okay, so she's losing strength, and right about here is half of her clench force. Okay, so this amount of time is what it took for Gail to get fatigued by half. Okay, so then we're going to look up here. Delta T, it took 71.042 seconds to fatigue. So then I'm going to do the same thing over here. Okay. Once again, display waveforms. Once again, I'm going to highlight each of these peaks and get the average for both. Finally, once again, her maximum clench force is about 40 again. And so we're going to highlight until her clench force is about 20. There we go. So about 20. And so it took 24.4 seconds to reach fatigue in this arm. So that is the for how you analyze data in BIOPAC on a school machine.